Today we're going to be talking about how to solve quadratic equations by factoring. All those factoring skills and exercises we've been doing the last couple of days are going to be useful to solve these equations. It is important to know that if we're going to be solving by factoring, your equation must equal 0. And we're going to talk more about that in a minute. So a quadratic equation in one variable can be written in the form ax squared plus bx plus c, or in standard form, and we can now go from standard form to factored form and solve. And remember, it has to equal 0. Now, the solutions to a quadratic equation can be referred to as the roots, and are also known as the zeros and x-intercepts. So I know that this is going to be confusing for a while because we have 4 different terms that essentially mean the same thing. We just use them in different situations. Like if we're talking about graphing, then we're just going to say we're going to find the x-intercepts. So if the left side of ax squared plus bx plus c equals 0, that standard form equation, can be factored, then the equation can be solved using the zero product property. And what that is, we have the box down here for it, is if I have 2 things that are being multiplied, I have 2 things, A or B, or A and B, one of them has to equal 0. Both could equal 0, but at least one of them has to be 0. If you think about it, 0 times anything is 0. So if I have 2 things being multiplied and my result is 0, at least one of those things I was multiplying originally has to be 0. And we've kind of done this already with our x-intercepts. This is a standard form part of a quadratic function, and if this equals 0 like it does right here, that means each part of my equation can be set up equal to 0. X plus 5 equals 0, 0, or x plus 2 equals 0. And then x could be minus 5, which is the opposite of that first factor, or x equals negative 2, which is the opposite of our second factor. So we're just kind of coming back full circle. So let's look at example 1. Solve the equation. Now, please be mindful that even though we're solving by factoring, once we factor, we're not done. We have to solve. So at the end, I should see x equals something. We can factor this, and since a is 1, we just need 2 numbers that multiply to negative 42 but add to negative 1, and that's going to be negative 7 and positive 6. So my solutions, the opposite of negative 7, so x equals 7 is one solution, or opposite of this is x equals negative 6. So those are my 2 solutions. Example number 2, what are the roots of this equation? This equation does not equal 0 right now, so we have to subtract 35 first, and that is a very common mistake students make. So then we get x squared plus 2x minus 35 equals 0. Now that the equation is equal to 0, we can go through and factor. 2 numbers that multiply to negative 35 but add to positive 2, that's going to be x plus 7 and x minus 5. The solution is going to be x equals negative 7 and x equals positive 5. All right, down here, I'm going to do a couple of them, and then I'm going to ask you to do a couple as well. The first one I'll do is this solo. It says solve the equation and find the roots, which again just means the solutions or the zeros. We have f squared minus 121. When I don't see a b term, like we don't see an f to the first power anywhere, if we don't see that b term, I automatically think that could this be a difference of squares? And this one is, because the square root of 121 is 11, which means this factored form is f minus 11 times f plus 11, meaning my solutions will be f equals negative 11, or positive 11 for that factor. And for this one, it'll be f equals negative 11. So those would be your two solutions. I want to do this team one, because in this team one, this is not equal 0, so we have to get everything to one side. What I like to do, or what I think you should do, and highly suggest, is that you always move your terms to the side of the equation that has positive x squared, or your squared term. So this is positive z squared. So I'm going to subtract 2z from both sides, and I'm going to subtract 30 from both sides. On the left side, that's going to give me z squared minus 5z, z, minus 36 equals, these go away. Now that this equation is equal to 0, we need two numbers that multiply to negative 36 and add to negative 5. That is going to be z minus 9 and z plus 4. Negative 9 plus 4 is negative 5, and negative 9 times positive 4 is negative 36. So we have z equals 9 and z equals negative 4. I want to look at this one down here, because this one could be factored using one of our shortcuts. But if you forget about your shortcut, you could still do factor by grouping. Both of those will work. But I'm recognizing that this is a perfect square trinomial, because 1 is a perfect square and 4x squared is a perfect square. So you could write this as 2x plus 1 times 2x plus 1 equals 0. And do not fall in the trap of thinking, oh, x is going to be negative 1, because that's the opposite. Remember, the zero product property says that one or both of these things, it has to equal 0. So 2x plus 1 has to equal 0. Now you may be asking, why didn't I do that up here? Why didn't I say, x minus 7 equals 0 and x plus 6 equals 0? Well, you could. Okay, x minus 7 equals 0, but when you add 7 to both sides, you're going to get x equals 7. You could have done that here. X plus 6 equals 0. All right, you subtract 6 from both sides, x equals negative 6. It's just when you have just an x here without a coefficient, it's easier just to get right to the answer. But here we have 2x plus 1. So what's going to happen is when we solve this, we have 2x equals negative 1, and we divide both sides by 2, x is going to equal negative 1/2. And you might recognize that this is the exact same thing, so we don't need to go through and find and do the same process, because it's the same thing. So we only have one solution to this equation, and it is x equals negative 1/2. All right, I'm going to ask you to pause the video and try to solve these two problems. Once you're done, you can unpause it to see what I got, and you'll see my work to see if it matches yours. Okay, look at what I got for this pair answer. I first had to subtract 3 from both sides to make this equation equal to 0, and then I did factoring by grouping. When I factored by grouping, I got my two parentheses, and one of them was x minus 3. and the other one was 2x plus 1. And for x minus 3, we could see that, oh, x equals positive 3. We're good to go. And the other side, you can see that I set 2x plus 1 equal to 0, subtracted 1 from both sides, and then divided 2 from both sides and got x equals negative 1/2. For the solo problem that I asked you to do, that was a difference of squares. When you factored that, you should have gotten 3x minus 11 times 3x plus 11. And then you set both of those equal to 0 separately. And after the algebra, we get x equals 11 over 3 and x equals negative 11 over 3. So as I was mentioning earlier, the zeros of the function are kind of the same as finding the x-intercepts or finding the solutions of the quadratic equation. So remember that when we have a quadratic function in intercept form, your zeros are p, so your x-intercepts are p comma 0 and q comma 0. And because the function's value is 0, the y value is 0 at both of those, when x equals p and x equals q, p and q are called the zeros of the function. And if you remember up here, we set the equations equal to 0 to solve the quadratic equation. To find the x-intercepts or the zeros of a quadratic function, is going to be the same idea. We're going to set these quadratic functions down here equal to 0 and do the exact same process. So down here, we want to write this in from standard form to intercept form. A is equal to 1. So what are two numbers that multiply to negative 28 but add to positive 3? That's going to be 7 and negative 4. So my intercept form is going to be this: y equals x plus 7 times x minus 3. And the directions say identify the zeros, not the x-intercepts. So the zeros would be x equals negative 7 and x equals positive 4. If it asks for an intercept, I would need a point, an x comma y. Letter B. Again, we have our standard form here. Our a value is 1, so two numbers that multiply to positive 4 but add up to negative 4. That's going to be negative 2 and negative 2. So our intercept form is x equals, or y equals x minus 2 times x minus 2, or x minus 2 squared. And you could look at this and say, well, that's vertex form, and I would agree that is vertex form as well. However, we can simplify this because it's the same x-intercept. Solution is going to be x equals 2. All right, for this problem, what we're going to do is we're going to factor this. And remember, I said that when our a value is negative, we want to factor out a negative number. So I'm going to do that when we get to that part. But first, we need to discuss and think about what two numbers multiply to, negative 5 times negative 1 is positive 5. So two numbers that multiply to positive 5 but add up to positive 6, that is 5 and 1. 5 and 1 add up to 6, and 5 and 1 multiply to positive 5. So we have negative 5x squared plus 5x plus 1x minus 1. Then factor out from these two. I'm going to factor out a negative 5x, and I'm going to be left with x minus 1. And from here, I'm going to factor out just a 1, and I'll be left with x minus 1 as well. So then I'm going to write this as x minus 1 times negative 5x plus 1. So this would be my intercept form. Y equals x minus 1 times 5x minus 5x plus 1. And you could have that reversed and you'll get the same answer. Now, x equals 1 and negative 5x plus 1 equals 0. Negative 5x equals negative 1. And then x equals negative 1 over negative 5, which is equal to 1/5. So those would be our two zeros, 1/5 and positive 1. All right, I'd like you to find the solution, or sorry, not the solution, the x-intercepts of these functions here. So go ahead and pause the video, try these, and once you're done, we can look at the answers. All right, so here are the answers and the work. You can see that I found my solutions, and then I put them, or my zeros, and then I wrote them as intercepts, because if you're being asked to write stuff in intercepts, you need to have a point, like I was saying earlier, 1/2 comma 0. I wanted to point out letter B because when you factor it out in x, that is also one of your intercepts or one of your zeros. Now this problem down here, so you have a rectangular vegetable garden in your backyard that measures 15 feet by 10 feet, and I want to double the area by adding the same distance x to the length of the width of the garden. Find x and the new dimensions of the garden. So the original area is 150. My new area is going to be 300. So what's going to happen is I'm going to add x to 15. So x plus 15, and I'm going to add x to 10 because I'm adding the same amount to both dimensions, and this needs to equal 300. Now you might be tempted to say, oh, x equals negative 15 and x equals negative 10, but this equation does not equal 0. So what we actually have to do is we have to FOIL this out, so then we can subtract 300 from both sides, and then we can factor that. So when we FOIL this, we get x squared plus 10x plus 15x plus 150 equals 300. When we subtract 300 from both sides and combine like terms, we get x squared plus 25x. Subtracting 300 is negative 150. So now we need to factor this because this is equal to 0. And we're going to get our two solutions. Two numbers that multiply to negative 150 but add up to positive 25. That is going to be x plus 30 and x minus 5 equals 0. So then my two solutions are going to be x equals negative 30 and x equals positive 5. Now, it would not make sense in the story problem for my x to be negative 30 because my dimensions would be negative at that point. So we don't care about this one. We care about our positive solution. So what that means is that our two dimensions are going to be 15 plus 5, or 20, or 10 plus 5, which equals 15. Those are my new dimensions. All right, with this problem, we know that when we multiply these two things, we should get 16. We need to find x, so we have to multiply this out. We're going to get 3x squared plus 2x equals 16. When we subtract 16 from both sides, we get 3x squared plus 2x minus 16 equals 0. So now we need to factor this. And we can factor by grouping. 3 times negative 16 is negative 48. Two numbers that multiply to negative 48 but add to positive 2. That's going to be x equals 8. Or sorry, not x equals 8. Sorry. That's going to be 8. and negative 6. So 3x squared plus, let's do minus 6x plus 8x minus 16 equals 0. Can factor out a 3x, and we're left with x minus 2. Can factor out an 8, and we're left with x minus 2 as well. That then will give us x minus 2 times 3x plus 8 equals 0. Now this one is going to be x equals 2, which I know is going to be the right answer, and this is why. If you do this part, 3x plus 8 equals 0, you get 3x equals negative 8, and I'm going to get a negative answer, x equals negative 8 over 3, which we know we can't have. We can't have a negative side length. This side length is x right here. We can't have a negative side length when we're talking about area. So that's how I know that this is the correct, like that x equal 2 is going to be the correct answer. Let's revisit these revenue problems that we solved using our graphing calculators and talk about how we could now solve those by hand. So remember, x is the number of price changes, and R of x is your revenue. And how much did the company charge in order to maximize the revenue? Well, first we need our equation here. Rx is equal to number of price. So we have two parentheses. One of them is going to be price. So 30 plus 1x, because we're increasing price by 1 and we start at $30 a month. And 1,500 minus 25x. That's our customers, and we're decreasing by 25. Well, now we know that we could set each of these equal to 0 to find our x-intercepts. Because remember, in intercept form, our vertex is halfway in between our two x-intercepts. This is in intercept form. We just don't have it saying x plus a number or x minus a number. All right, so this one is going to be 30 plus x equals 0, or x equals negative 30. So one of my x-intercepts is negative 30 comma 0. Now this one, 1500 minus 25x equals 0. That's going to give us 1500 equals 25x. And when I divide both sides by 25, that's going to give us 60. Meaning my other x-intercept is at 60 comma 0. The halfway point between these two is 15. So 15 price changes should happen in order to maximize the revenue. So 30 plus 1 times 15 is $45. So the company should charge $45 to make the maximum revenue. And what will that maximum revenue be? Let's plug that in down here. I guess we don't need that part. So 30 plus 1 times 15 times 1500 minus 25 times 15. Now we know that this part will be 45. And we can just type the other part in the calculator and be done with it. This part is 1,125 for a total maximum revenue of $50,625. All right, so I hope that going through these helped you with solving quadratic equations by factoring, and all the problems we can now solve with this tool and the different terms that we can use. So thank you for watching this video. Make sure to like and subscribe.